Hello and welcome once again. We've already crossed the formatting cells bridge in Excel. We are on analyzing data and formulas. We will make haste progress on this one. Right, so by the end of this particular session, what should you know? You should be able to enter formula using quick ask analysis tool, build logical formula with if function, build the logical function with an AND function, run the value, build a statistical formula with counter function, a date function, work with equation tools, and of course control worksheets, calculations. Okay, right. So let's just get straight to the point. How do we deliver on this very well? Using the quick analysis tool. Now look closely to this event we're going to have here. Now this is a template. Like I said, I will share this with any of you. You can create your own, generate your own values, cells and all. You've come so far. What you do with what you're learning is much more important to me. So we are working with this data tool we have here. And I'm happy every one of you has a licensed version or copy of the Microsoft Office 365. Now, the quick analysis tool is an excellent new feature in Microsoft Office that everyone must embrace. It's such an excellent tool if you ask me. So if you select a range of cells with values and data like you see right here, if you have anything similar to this, it doesn't have to be exactly this. Okay, I hope you can see it clearly. Right, I can select that range of search of what do you call it, of cells, and then this is where we have the quick analysis tool. It's on the home tab. On the far right of the ribbon, we see this analysis button here, or it's a tool, it's a command. Okay, once you trigger it, see what will happen. Watch closely. Watch closely. I know my image is covering quite a number of things. Okay, now do you see what is happening here? There have been some analysis performed by default intelligently by the system. So we have some fields that interest you the most. Well, they've considered quarter one, quarter two, quarter three, and then use the values that are in there to distinguish between certain flows that we can see over here. Intelligently, it has picked all the rows and then provided some values as well. It may not necessarily be as accurate as you may want, but it gives you a very quick analysis of the entire data in the table, and then generates some charts, some sums, some averages, and other selected totals for you. It goes on and on and on. Field positions. So it has picked these field positions and it has plotted against all these New York to Vancouver, the values that has been provided here. So obviously you see that there is one that is tallest. That pretty much may be, well, I wouldn't want to assume, but of course this is the frequency of field positions it has created. Several other charts, as you can see from here. Okay, if I limit my selection to just this portion, for example, and then I ask you to analyze the data, it will come up with some intelligent outcome. So per each field, you see it is 1, 2, 3, 4, each color representing a quarter, 1, 2, 3, 4, and then for all of the various countries, all the various cities. So depending on the values that each of them has, and it has done some plotting as well. Quarter 2 and field quarter 4 appear highly correlated. Intelligently, it has seen that there's some high correlation between this field and that field, among others. Multiple values by field 1, multiple values by, basically there are several more results that it can display for us to view. By and large, all we're saying here is that this is one of the excellent features of the quick analysis tool. It will allow you to quickly format, chart, or analyze data by calculating sums, averages, and other selected totals. It allows you to quickly format, chart, and analyze data by calculating these sums and other totals. We cannot overemphasize on this. So you can play with this as often as you can with any data that may come your way. Right. Now, we can also build a logical formula with if function. We're going to do more of this. This is where my interest really lies, especially those of you who have plans and other intentions to build a career in computer science or IT or any of the related fields. Now, logical formulas make calculations based on stated conditions. Okay, they make calculations based on stated conditions, which results from a logical test. They make calculations based on stated conditions resulting from a logical test. And there are three parts of the if function. So, for example, we have the logical test or condition. An action if result of the logical test results turns out to be true, and an action if the result of the logical test is false. And we have these operators that we often use in instances such as this. Okay, so we have the less than operator, greater than operator, and then the equal to operator. And we have the less or equal to, greater than or equal to, and not equal to. These are primarily the operators that form key to this particular episode. So let's demonstrate this. For example, is that okay? Okay, so let's look at it clearly here by way of demonstration. So we have various columns here. Of course, these are the cities, their various quarters, and their revenues and their total revenue, which is a sum of all their quarters that resulted in this figure here. What resulted with this value, I don't know, but these are input values that is in this template. We really don't care. We are not doing accounting here, right? So our interest here is this. You notice we have the target percentage increase, which is 15%. This cut across every one of these cities and their revenues. So how we in a document like this, if you belong to a company, an organization, you want to know, based on the annual increase of these cities as far as their revenues are concerned, who got more than the target percentage increase and who got less than the target percentage increase. How do we distinguish between one group from the other? I don't know whether this conversation makes sense. Okay, so maybe in this Excel sheet you want those, for example, if you look at this New York figures here, the annual increase value we have put here is 75.45%. Okay, clearly this is more than the 15% target, so their target has been met. The outcome here is negative 0.02%, which clearly means that they have short-lived in terms of the target that is expected of them in the case of Los Angeles. Are you getting the whole conversation here? So in this section here, year revenue target, the display of information we want here is either probably target being met, target being missed, maybe something like that. That's what you want to appear there. But on which condition, on which logical statement are you going to conclude that something has been met, which implies true, or something has been missed, which implies false? That logical statement here is, has this annual increment here exceeded the target? If yes, met. If no, missed. I hope you follow the conversation. All right, we've been making a lot of these decisions in so many applications you've interacted with. But of course, this is just the beginning of the whole journey. All right, we're going to do more complicated things than this in your programming courses. So how do we begin this? So we indicate, let me zoom in carefully so that we get to see exactly what is happening a bit more. And you can also pay attention to what happens in the formula bar at the top here. So we begin with an equal to sign and then write our if statement and open the brackets. Now you notice that they've indicated that you should state your logical test. The value, if true, and the value if false. So our logical test literally is if the target value, which is if the value here, right, is greater or equal to this value here, 15. Now this B13, the cell B13, which contains the target value, because we are going to apply it to all the other rows, okay, we have no other choice but to render this an absolute reference as we did in the first lesson. Okay, so we introduce the dollar symbol here, so we lock the column and then we lock the row. Right, now after this statement, if this is greater or equal to this, all right, then the statement will read met, else it will be missed. Are you making sense out of this? If the value in cell H3 is greater or equal to the target percentage increase, which was the 15, the cell which contains it is cell B13. If it is greater or equal to, then it should resolve to met, target be met, or it has been missed. Let's see how this actually plays out in real action. So because this 75 is greater than this 15, by default it has translated into met. So let's see whether this will repeat itself should we get to this cell or that cell. So all I need to do is drag this. There will be some relative referencing and absolute referencing. The relative referencing will have to do with an adjustment to row 4 and then column I, but the relative referencing will be the 15% target increase that has to be the target for every single one of the cities. So let's see what happens here. Clearly, target has been missed. If you move further down, target has been missed. But when we move further down here, target has been met, and of course here target has been met, and all of these things happen seamlessly just because of this function that we placed in there. So this is what we refer to as the building some of these logical tests to achieve such goals. Okay, so this is building a logical formula with if function. Logical formula with if function. We hope this makes some sense so far. Okay, now that's the if function. We can also look at the end function. The end function. Now the end evaluates all arguments. The end evaluates all arguments and then returns true, okay, by way of display when all logical tests are true, and it will return false, okay, by way of display if one or more logical tests are false. So what do we mean by this? Now, in comparison with what we did just previously, if the outcome was greater, so if the H3 was greater than the B13, okay, if when the 74 was greater than 15, the target had been met, okay. But when it was less than, in the case of the subsequent cities revenue percentages increase, it turned out to be missed. So the condition was, if it is this, then this, else is the other one. But in the case of end, we provide two conditions. Those two conditions have to be met to resolve into a true statement. If the two arguments, even if one of them turns out to be false, the outcome will also turn out to be false. Unless the two resolve to be positive, it will never be true. That's why we say end function. Okay, the or function will return true if any of its arguments are true, and the not function, logical function will reverse the value of its argument. So these are some of the examples between these three key things. We have the what do you call it? It's the function here, end. So if you look at this formula clearly, let me even zoom in so that we can appreciate it more closely. So if you look at these end, the end function, we are saying that in this case, what you are seeing, if a1 is greater than 5 and b1 is greater than 25, these are the two logical tests. These two have to be true to get a true result. Even if one is false, the whole outcome is false. In the case of the OR, okay, a1 is greater than 5 and b1 is greater than 21. Okay, this will result in a true outcome. It's either one or the other, so there's always a true statement, a true outcome in there. Not will always return the reverse of it. Maybe we should look at the demonstration to appreciate this concept much clearer. Okay. Now, if you look at this same document we are dealing with here, okay, let's look at this column. Field positions quota. We have field positions, number of field positions, and the quota that has been provided. So, for example, if in the job space they have room to accommodate 381 people, but the field position is 2.13, then there's a bonus value that exists. And this bonus value, we want the condition to indicate we want to use the end condition or logic statement to satisfy this field. So we can indicate that and okay, J3, which is this section, okay, is greater or equal to K3, okay, if this is the situation, all right, then you can indicate that I3, okay, I3 is the condition here, the outcome of what happened here, which is here, the target revenue, okay, has indeed been met. Okay, basically that. Okay, so we're using the end function. So we have two parameter arguments, J3 being greater or equal to K3, and then their I3 also translating into met. Anytime it is less, it translates into a different outcome, because then eventually it's not going to be met. In some cities, we have the missed result for them, as you can see. So let's run this and see. So this is bonus is false. Why do you think it is false? Is J3 greater than K3? No. J3 field position for this column is 2 and 3. So obviously field positions for this is greater than, field position quota is still greater than field positions. So even if the target has been met, the condition bonus here is false. Let's see how it translates now there. This will also be false, because the resolution here is this is missed. As long as one of the arguments is not true, it will result to be false. So of course, field position is 452. Field positions quota is 220. So the first part of the argument is correct, but the second part of the argument is wrong because it is missed. So it will translate into false. Let's keep on and see whether it will have any true. This has also resulted into false. And let's see what will happen here. This is also false. But what would the situation here? This has turned out to be true. We have one true resolution. Yes, as you can see. So if you look at this carefully, J7, cell J7 is 464. This value is clearly bigger or greater than 116. First part of the argument is correct. Has I7 been met? Yes, it has been met. So bonus, they are indeed true, indeed. So these people don't deserve bonus. These people don't deserve bonus. These don't deserve bonus. These people don't deserve bonus. This group indeed deserves bonus. Are you seeing how these things play out? Maybe it will take some time for you to settle in or assimilate some of these things, but that's why this is a recorded session. So you can play it back and then adjust your scenarios and give it a shot in certain ways as you may wish to clearly appreciate what we are discussing here. Okay, right. We can also talk about a few more other things. We'll just do these ones quickly. You give it. I'll give you the privilege. If you go through thoroughly the reading material assignment, you have step-by-step approach to delivering on all the things that I'm discussing with you. So that will be more straightforward. I've done a lot of explanation and talking than that will show you, but that clearly outlines what stage by stage you should do. So I'll leave some potholes deliberately for you to go and fill in those gaps. So we can have round a value with a function. You can round a value with a function. Okay. So you can round a value or formula result to a specified number of decimal places by using the round function, and then the resulting rounded value is then used instead of the original value in future worksheet calculations. It's quite simple. So you only write the round statement equal to round, and then put the values in there. So no matter what the resultant value of that variable, say cell in a particular cell is, it will be rounded to that particular decimal place that you will define. But that is quite straightforward. So you will see an example of that in the key text. We can also talk about building a statistical formula with a counter function. We made mention of this. Now, to count non-blank cells more precisely, or to incorporate these calculations in the worksheet, you can use the count and then counter functions. Then the count function tallies the number of cells in the range that contain numeric data, including numbers, dates, and formulas. And then the counter function tallies how many cells in a specified range contain any entries like numbers and so on and so forth. So we can have, for example, the formula counter equal to counter, say cell A5, and then that will return the number of cells in the range that contain numeric data. So, I mean, by way of demonstration, let me just show you this quickly. If we go to cell A, we have only alphanumeric characters, but here we have quite a number of other things. So we can just pick from here. So we can write here, say count, okay, and then we'll select this range of cells, for example, okay, and then we'll close in the brackets. Now we have 10 as the answer, but how many cells do we have in the range that we selected? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and it put 10 here. So there are 2 cells that have been excluded from this count because that's counted only 10 fields with numeric data. Okay, so this is 15%, but those that we have that has numeric data is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Quarter doesn't qualify either because there's some alphabet also in there. Are you getting the logic here? Right. And then if we write counter here for the same group, we'll get 2. So for example, we can say counter and then reference the same number of cells at the same time, close the bracket and hit enter. Now this has included the 12, the entire 12. So it returns the number of cells in the range that are not empty. The counter is the one that are not empty. So if we want to put the same count here and drag it here, it gives us 11. This is not empty. It's not empty from quarter 2 all the way up to Vancouver value here. But this is empty, this is empty. That's how come we have only 11. So it's pretty much straightforward and simple, and nothing to make complicated. Okay, we can also enter a date function. Okay, you can enter a date function. Excel includes date functions to make it easier to calculate dates and time related results, such as the current date or the time between events. You should know that although the results of all date and time functions appear by default in worksheets in familiar looking dates and time formats, so Excel will actually store some of these these values. You store them as sequential serial numbers and use these numbers anytime that you want to perform some form of calculation where necessary. Okay, so for example, if you have, say, January 1, 1900, if it's assigned a serial number 1 and then the dates are represented as the number of days following that day, then you can see that the serial number of the dates by using date value function or by applying the number format to that particular cell. That is possible. So for example, to see the serial number of January 1, 2021, you would rather enter, say, date value of that. You can write this in a cell and the result will be the serial number 4197. You can try that for maybe 2022, for example. So you can just pick an ordinary cell here and then put inside here date value and then put in the what date is today's date. As at the time I'm doing this recording, you'll be shocked to know, but 03 2022. Okay, that's it. So today's date is quite different. The serial number of this date value is 44650. Right, quite a different figure from what 2021. Excuse me, my apologies. Represents, but they are quite different things entirely. Okay, right. So Excel actually equation tools allow you to insert many common equations, such as the area of a circle and the Pythagoras theorem. There are a whole lot of things. If you want to activate the equation symbol, depending on which cell that you want to deal with, you can trigger that by holding Alt and Add plus. Oh, sorry, still things I want to do somewhere. Some what do you call it? Some calculation or something. Okay, because of the nature of this particular Excel workbook, but that is just basically it. There are a lot of formulas, functions that we can take advantage of as far as this platform is concerned. Okay, so let's take notice of this. Right. So if you want to insert an equation, we have options. You can just click on the equation tab, you go to insert and go to equations, and then it will trigger this for you. Like I'm saying, we have a lot of things you can do: Pythagoras theorem, fractions, operators. There are a lot of things, so many equations that you can focus on. We have area of a circle, we have the binomial theorem, expansion of a sum, Fourier series, Pythagoras theorem, as I made mention of, quadratic formulas, Taylor expansion, and a few more. You can write ones for your own as well. So wherever you stand, you can just put your equation and then you are sorted out. You can also compose your own equations and formulas along with many available mathematical symbols. Okay, so that is about that bit. That's just about that bit. As we are about to conclude on this one, we have automatic recalculation of all values. All values getting recalculated if the data is changed. And we have a manual calculation option as well. So if I go to the settings of my um, office application, formulas. Um, you have the option calculation options. By default, it's set to automatic, and you can also set it to a manual state so that you can recalculate everything for yourself manually. But by default, the automatic button is toggled. Okay, so that's just for your information. Okay, right, so that was just a quick demo on that. So this actually brings us to the end of analyzing data and formulas. Like I've always said, this is just taking baby steps in this particular journey, as there is more to this that we have done. So we'll move on to the very last session for Excel, and then I guess we'll be good to go.